Welcome to section 3.4, Radian Measures of Angles. After this video, you should be able to answer these questions. What is a radian? What does it mean to subtend an arc? How do we calculate radian measures given degrees? And how do we work with radian measures on our calculators? How do we convert from radians to degrees and vice versa, manually and on our calculators? Which angles should we memorize both their degree and radian measures? All right, well, let's start with the first question. What is a radian? Well, here's a surprise. A radian is a radius. Who would have seen that coming? But what does that mean? Well, here's a website that explains that a radian measure is just the arc length around the circle divided by the radius. A radian is a radius wrapped around the circumference of our circle. If I take one radius and I wrap it around, the angle that's created by wrapping that one radius around the circumference is known as 1 radian. If we want to figure out how many degrees are in a radian, we find out that it takes a little bit more than 3 radians to cover half a circle. In fact, it takes 3.14159, or pi, radians. So 180 degrees is the same as pi radians. So 1 radian would be 180 degrees divided by pi, or a little bit more than 57 degrees. The great thing about this radian measure is that it doesn't matter how large the circle is we're working with. If we wrap 1 radian around the circumference, it will always be the same angle, 57 degrees. So regardless of whether I have a 1 unit circle or an x unit radius for the circle, the same angle is subtended for the circle if we wrap 1 radian. To convert between radians and degrees, we take that proportion that it takes pi radians, or 180 degrees, to wrap halfway around the circle. They're equal to each other, so we can create this proportion. If we want to find the radian measure of the angle given degrees, we'd multiply the degree measure by pi over 180. If we want to find the degree measure of theta, if we start with radians, we multiply the radian measure by 180 degrees over pi. Let's look at some examples now. Here I want to convert 225 degrees to radians. So I take my conversion factor, and I take 225, and I multiply by pi over 180 degrees. We can see that the units will cancel out, and I'm left with radians. So I have 225 pi over 180. If I simplify 225 over 180, I end up with 5/4 pi. Let's look at another example. Only this time I want to go from radians to degrees. So I want to convert 4.73 radians to degrees. Here I would take 4.73 and multiply by my conversion factor, which in this case is 180 degrees over pi, because I want the radians to cancel out and end up with degrees. So I pull out my trusty calculator, and I take 4.73 times 180, and then I divide by pi. And I get 271 degrees. To find the radian measure of an angle whose sine is 0.4, I need to take the inverse sine of 0.4 in radian mode. So I pull out my calculator, I go to check my mode, and I see that I'm already in radian mode, so I should be okay. And I ask for the inverse sine, of 0.4. And I end up with 0.4115. Let's look at another example. Find the degree measure of an angle whose sine is 0.4. Now I have two options. I've already found the radian measure, so I could convert the radian measure to degree. Or I could go back into my calculator. I can take that radian measure and convert it to degrees, which would mean multiplying by 180. And then dividing by pi. And we get a little bit more than 23.578 degrees. Another option would be simply to take the inverse sine of 0.4 in degree mode. So I go in and I change my mode. And I can go back and ask for the inverse sine once again, and I get the same answer. If I want to find the exact value of the tangent of pi over 6, I need to know which special angle we're referring to when I ask for pi over 6 radians. So I need to convert pi over 6 to degrees. And we do that by multiplying by 180 over pi. My pi's cancel out. I get 180 over 6, which is 30 degrees. I draw my 30, 60, 90 triangle. And I see that the tangent of pi over 6 would be 1 over the square root of 3. Now our calculator can work with both radians and degrees as long as it knows which mode we're interested in. Currently, I'm in degree mode. So if I type in 25 degrees, I can get the degree sign in the angle menu, option 1, and it'll tell me that 25 degrees is 25 degrees. But I can also ask for 25 radians, and I do that by going back into the angle menu, second, apps, and our third option there is a little r, which means radians. I'll choose that, and if I ask for 25 radians while I'm in degree mode, I'll get an answer of 1,432 degrees. Since there are about 6 radians around a circle, and 25 is a little bit more than 4 times that, if I take 360 and multiply it by 4, I should get a number close to 1432. Now, if I go into radian mode and I ask for those same two values, if I ask for 25 radians in radian mode, I get 25. If I ask for 25 degrees, or if I input 25 degrees in radian mode, I end up with 0.436 radians for 25 degrees. So that's what you need to know about radians from this section. And our final thought, there's a species of antelope that can jump higher than the average house. This is due to the antelope's powerful hind legs and the fact that the average house can't jump.